It automatically does it. All right, welcome to math. Let's do a quick whole body listening. Fourth graders, same for you. Fourth grade math students, listen up. Okay, so your ears are listening. Your brain is thinking about what is being said. Your mouth is quiet. Eyes are up here. Hands and feet are down and still. We're ready to listen and learn. So I want to go over. I see Leo is joining us.
He has to go on there twice, so I'm not sure what's going on.
All right, let's hope it works. Okay, so today in your Google Classroom, and you guys are here under math, we are going to do part 2 of our lesson. Yesterday we learned about our tens count bys, and today we're going to do some work with word problems. So I really want to think about, how do we know whether to multiply or divide? Everybody show me your fingers. We're going to make symbols today. This is multiplication. Everybody at home, show me this. And this is divide. Everybody at home, show me divide. Excellent. And we're going to be using one of the numbers in our problems is going to be, guess what? Our count by. Everybody say it. What's our count by? 10. So I see a little, let's see if I can fix that. So we can solve real world math problems involving tens, multiplication, and division. Yesterday, you guys came up with different things that come in tens, right, Sawyer? Like fingers and toes and packs of markers and packs of candy and gum. So today, I'm hoping we can read carefully. We're going to draw pictures. We're going to write equations with something called a variable. That's something new. And then we're going to reflect to see if our answer is reasonable. Before we do that, let's go ahead and review our count bys. We have now 3 different count bys. We have our 5s, our 2s, and now we have our 10s. So quite a few things to think about today. Let's start with our 5s. And we're going to do a little bit of division with them today too. So looking at our 5s, you can start at the top because that's one of our factors, or you can start on the side. We're going to look at this one going down vertically. Repeat them with me. Here we go. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. 4 times 5 is 5 times 5 is 6 times 5 is 7 times 5, 8 times 5, 9 times 5, 10 times 5. Now we're going to, can you come up here, please? Now we're going to do division. Watch how we do that on the multiplication chart. We just go backwards. 5 divided by 5 equals 10 divided by 5 equals 15 divided by 5 equals 20 divided by 5 equals 25 divided by 5 equals 30 divided by 5 equals 35 divided by 5 equals 40 divided by 5 equals 45 divided by 5 equals 50 divided by 5 equals. So you're going backwards, just like we said that division is the inverse operation of multiplication. We're flipping it backwards. Let's try it with our 2s. Let's do the multiplication first. Okay, we're going to look here. Let's just go, we'll go down today for this one. 1 times 2 is 2 times 2. 3 times 2. 4 times 2. 5 times 2. 6 times 2. 7 times 12. 8 times 12. 8 times 2. Whoa, that was weird. 8 times 2. 9 times 2. 10 times 2. Okay, so we have all of our products here. Now to do division, you're going to do the inverse operation. So we're going to say 2 divided by 2 equals 1. 4 divided by 2 equals 2. 6 divided by 2 equals 3. Say it with me. 8 divided by 2 equals 10 divided by 2 equals 12 divided by 2 equals 14 divided by 2 equals 16 divided by 2 equals 18 divided by 2 equals 20 divided by 2 equals 10. So one of the problems on your test was this. It said 18 divided by 2 equals what? And nobody got that right on this morning's test. Not one person got that right. So if you have a chance to do that problem again today, what could you do? Can we put the hand sanitizer away? Thanks. We don't need it right now. Charlie, what could you do to answer that question? 18 divided by 2. What's the answer? How would you know? What could you do? Yeah. So what times 2 equals 18? What if you don't know that? What can you do? You count by 2s. Let's do it. Mrs. Harrison, can you hold them up? 2, 4, 6, 8, 10, 12, 14, 16, 18. How many 2s, Gabe? 9. So you should have written 9. And I get it. This is division and multiplication at the same time can be tricky. But I wanted to go over that to make sure you understood. 18 divided by 2 is 9. All right, there are 9 2s in it because 9 times 2 equals 18, right? Okay, we have one more count by. Let's go across this time. We're going to look at our 10s. We added them in part of its cover. Say them with me. 10 times 1 is 10. 10 times 2 is 10 times 3 is 10 times 4, 10 times 5, 10 times 6, 10 times 7, 10 times 8, 10 times 9, and 10 times 10 would be 100. Now we're going to go backwards. 10 divided by 1 would equal 10. 20 divided by 2 would equal 10, right? 30 divided by 3 would equal 40 divided by 4 would equal 50 divided by 5 would equal 60 divided by 6, 70 divided by 7, 80 divided by 8, 90 divided by 9, and you could do it the other way too. 80 divided by 10 is 8, right? 90 divided by 10 would be 9, using those fact families. One thing we did on our exit ticket yesterday that nobody got right either, that I think because we had announcements going. Can I pull body, please, Haley? We had the announcements going. We had people in here, and it was so hectic that I'm not grading your exit ticket from yesterday, but I want to go over it. So how do you know that a number like 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100 here, how do we know those are count bys of 10? What do they all have in common that make them recognizable? Surname.
They all end in 0.
That is it. That's what I wanted you to write on your exit ticket. Surname, you're rocking it, honey. You are getting this great. If a number ends in a 0, you know it's a multiple of 10. So all of these products are multiples of 10 because they have a 0. So on your exit ticket, all you had to write was they end in a 0. That was it. That was what I was looking for. So I will not grade that because look how simple that was. But it was a little confusing yesterday, huh? Does it make sense now? Can you tell that they all end in a 0? So if you said 5 times 10 is 46, would that be right? First of all, it ends in a 6. You know it can't be if you're multiplying by 10. It has to end in a 0. So that should help you check your work and make sure it's reasonable. All right, let's get this erased. And we are gonna move on to some of the things we need to do when we are problem solving. Does anyone remember looking at our poster, and I'm gonna put it up on the board, what the first thing we do when we are solving problems is? If you know, would you raise your hand at home or write it in the chat box? If you're here, raise your hand so I know. You remember the first step when solving word problems. What is it? You've got to read the problem carefully, right? So read the problem. We're going to do that. But what if we're not visualizing it? That's what we're going to talk about, Lucas, because sit up, but we need to be able to see if we're multiplying or if we're dividing. I'm going to tell you right now, we're either going to multiply or divide today. Gosh, I hope that's right on the problems. That's what our focus is. That's our learning target. So how do we know the difference? Well, we're going to have to visualize. Are we breaking things? Do we have a total amount? And are we dividing it? Divide means breaking it up into pieces, right? Into groups, equal groups. Are we doing that? Or do we already have groups and we want to know how many there are all together? That's what we're going to have to visualize. Then we want to retell, be able to retell the problem so we're thinking about it. Does it make sense? It's just like reading a book and retelling it like we did with Ada the scientist. Are you comprehending it? Are you understanding it? We're going to look for clues to help us. We're going to model the relationship by drawing a picture. We're going to find the unknown and we're going to reflect and see if the answer makes sense. Okay? So real quick, before we even start, I want to share with you some of the things to think about today. And I think we need to make an anchor chart of this to hang in the classroom. Okay, so when you're either going to multiply or divide today, right? So multiplication. What do you already know about multiplication? What do you know, Sunny? Okay, so it's the inverse of division. And then I could write this is the inverse of multiplication. What else do you know? Thank you, Sunny.
Multiplication is repeated addition.
I am so glad you said that. It's just repeated addition.
I said that because you tell us that every time we do that.
And you just made my day. You're actually listening, Abby. That's fabulous. Evie. She loves it. It's the best math she's ever learned. Okay. Anything else you already know about multiplication or division? Okay. I'm not sure we would. What do you think, Mrs. Harrison? Would you say division is repeated subtraction? I've never heard it. I can see that. The only thing is when I think subtraction, you end up with less, right? But this is more groups. Can we reword it a little? Division is like repeated subtraction? Okay. It is like repeated, but you're not giving it away. I guess you are. The cookies got given. You are separating them. Yeah. Serne. Thank you for your thinking. That's because I said it's the inverse of division. Multiplication is the inverse, and division is the inverse of multiplication. All right, here's what I want you to try to put in your head, okay? So I want you to listen right now. When you're solving a multiplication problem, You need to find the total. You are looking for a total amount, for a total number. Do you know what I mean by total? Like all together, right? What are you thinking? What it equals. Yeah, the whole thing, all of it, a bigger number. You're looking for a total number, a bigger number. But in division, you have the total. You already know how many stickers you have. You have the total number and you are putting them into equal groups. You're trying to find either the group size or the number of groups, but you're looking for a smaller number, right? You're not looking for a big number. You have the total number. You are looking for the number of groups or the group size, because you're actually dividing something up. Sometimes you're going to hear the word divided, right, in the problem. If it says that she divided up her stickers between her friends, guess what you're going to do, boys and girls? You're going to divide. But if you hear she has 3 packs of stickers with 5 in each pack, how many stickers does she have? Well, I got to find the total. I want to know how many stickers she has. Then I'm going to multiply, right? Because I'm looking for a total amount. If they're giving me the number of groups and the group size, I'm multiplying. I hope that helps a little as we look at our problems. We're going to refer back to that and throughout the year, actually. All right, so let's get rid of that and let's turn in our math workbooks. We're going to look at page 34. Page 34. So we're going to go back to what Eleanor said. She said that we are going to read carefully. I'm going to give you a minute. I hope at home you have your math workbook and pencil. That's all you need today. So Raimundo has 9 dimes. How many cents does he have? So yesterday, somebody said, Mrs. Aubin, dimes come in tens. And I was so excited. Was that you, Sunny? Because she was right. And guess what? We're going to talk about that today. So it's kind of hidden information. Dimes equals 10 cents, right? It's page 34. Mrs. Harrison, just because you put 32. That's okay. Page 34, everybody.
So just so you know, Mrs. Aubin,
Yes.
sometimes you get messages I don't get. So
Oh, how
if
interesting.
I do it privately to you or privately to me and someone getting, just so you know.
Okay.
I am answering them, just not always.
It doesn't show.
So if they want to ask me a question, I mean, so that my teacher to have them send it to me instead of.
You can send your questions to Mrs. Harrison because we don't see the same questions.
Yeah, I just wanted you to know.
Yep.
that, you know.
All right, Raimundo. What a name, huh? Raimundo. I love it. I've never had a Raimundo in my class. Has 9 dimes. So let's visualize this. You guys have seen dimes? Yep. Hold them in your hands. Pretend you're Raimundo. You have 9 of them. Let's draw a picture. 1 dime, 2, 3, 4, 5, 6, 7, 8, 9. And Sonny, tell me again, how much are those dimes worth? They're each worth 10. So you can put a 10 in the middle of each one. I'm not going to draw 10 dots because 10s are easy, right? So we have a 10 in, now I can visualize that. I see it. If you couldn't visualize it in your mind. Yes, August. Is it broken? Yeah, go ahead. There's an electric one right there. So I want to know how many cents does he have? Show me on your fingers. Are we going to multiply or divide? I'm looking for the total number of cents. What do you think? Do you agree? She says multiplication. If you agree, give me a thumbs up. Abby, why? Why do you think multiplication?
I think multiplication because
You're adding more and you're not getting rid of. Division is kind of getting rid of something.
Okay, dividing it up. So she says we're adding these up, right? It's repeated addition. And why else, Finn? He knows the answer. Anybody want to add on to why it's multiplication before we solve it? Awesome, because we're looking for a total. We don't have the total. So I'm going to let Finn tell me the equation. What do you think it's going to be?
It's going to be
9
times 9.
times 10, or you could flop it because of commutative property. And what are we going to get as our product, Henrik? How do you know? All we have to do is count by tens 9 times. Let's do it. 10, 20, 30, 40, 50, 60, 70, 80, 90. All right. Let's try one more together, and then we're going to do a little this work in breakout groups and together. Number 2. Oh, we forgot to reflect. Let's see if it makes sense. Raimundo has 9 dimes. He has 90 cents altogether. But that works, right? What if I said he has 900 cents? That wouldn't make sense. So we would have to go back and check our work. All right, Yoko has some dimes in her pocket. Yay. So we know these some dimes. And no other coins. She has a total of 70 cents. How many dimes does she have? All right, she has 70 cents. That is the total. We know they're in groups of 10. I need to know how many there are. Am I going to multiply or divide? Show me on your fingers. Can you show me either a multiplication sign like this or a division sign like this? Show me at home. Looking good. All right.
I think that I got some things for you.
I know. So I'm going to ask somebody who says multiplication. Why do you think that? Who said multiplication here? And would be willing to defend it. Henrik, why do you think multiplication? Hey, but do we know the total? It says total of 70 cents. When we multiply, what are we looking for?
The number.
We're looking for the total, but we already have the total. So could we be multiplying? We already have it, guys. We have to. Well, we're either multiplying or dividing. Who can defend their thinking for division? Suriname?
It gives us the total, but it gives us the total. So we need to figure out the rest of it.
Because they're in groups of 10, right? Because each dime is 10 cents. So we're dividing it by 10 because each dime is worth 10 cents. We want to know how many 10 cents are in 70. Go ahead and solve that. Count by tens. How many tens are in 70? Show me on your fingers. Josh, how many?
7.
How do you know? Did you count by tens? Till you got to 70? Excellent. Let's do it. 10, 20, 30, 40, 50, 60, 70. There's 7 tens in 70. Let's reflect and make sure this makes sense. Yoko has some no, let's put the answer in. Yoko has 7 dimes in her pocket and no other coins. She has a total of 70 cents. Does that make sense? 7 dimes in her pocket, she has 70 cents. Yeah? Thumbs up? Awesome. Okay, here is the problem you are going to work on in your breakout room. And Mrs. Harrison, I would love to do twos, pairs if we could. I'm going to read it to you first. In your breakout room, you are going to decide if it's multiplication or division. You're going to write an equation and write your answer together. Talk about it, unmute, and say, I think this, and this is why. And if you have a differing opinion, make sure you prove it. Say why you don't think it could be blah, 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 blah. And we're going to do the same thing, but the person next to us. Here's the problem. Jonah picked 40 strawberries. He gave them to 10 of his friends. Each friend got the same number of strawberries. How many strawberries did each friend get? I'll read it one more time. Jonah picked 40 strawberries. He gave them to 10 of his friends. Each friend got the same number of strawberries. I want you to visualize this. How many strawberries did each friend get? Okay, go for it. Mrs. Harrison's gonna, oh, I have to put you in breakout rooms. Oh, it worked for you. Okay, you can go in your breakout room. If you are here in person, I want you to work with the person next to you without getting too close. Good luck. We'll come back in a couple minutes. Am I okay to, okay.
Miss Harrison, I'm not in a breakout room. Yeah, there isn't anything popping up saying go to breakout room. Now there is. Okay, I'm gonna pick out of the can. Finn,
Can you explain what you got with your partner?
The strawberries one, me and him got 4.
Okay, what did you decide to do? Multiply or divide? Divide. Why did you choose division?
Because you already had the amount of strawberries and the amount of friends. So you needed to just know how many friends got strawberries.
Okay, so you already knew that he gave them to 10 of his friends, and you needed to know how many strawberries each one got.
Yeah.
Because we're not looking for a total, are we? Can you visualize it? I want you to be a listener, okay? You have 40 strawberries. You have 10 friends. You're passing them out one at a time until they all have fair shares. That's division, right? Because you already know you have 40 strawberries. I'm not looking for a total amount, a big number. So good job. And you got how many 10s are in 40? 4. If you agree with Finn at home, can you give me a thumbs up? If you agree with Finn at home, give me a thumbs up. Okay, we're gonna try one more and then we gotta move on to variables. But we're gonna do another breakout room, Mrs. Harrison.
Oh, okay.
But I'm gonna read it to you first. Here we go. There are 10 Space Command trading cards in each pack. Zoe bought 5 packs of cards. How many cards did she buy in all? Let me read it one more time. There are 10 Space Command trading cards in each pack. Zoe bought 5 packs of cards. How many cards did she buy in all? Okay, you're gonna figure this out with your partner. Decide if you're gonna multiply or divide, write an equation, reflect, see if it makes sense. What if I hit later so I don't join? I hit later. Okay, girls. Okay, you guys. Show me if you need 0 minutes or 1 more minute. 0, yeah, let's close it. No, you're fine. I wasn't sure if we needed more time or not. Welcome back. All right, I want to hear from somebody at home. Let's hear what you guys said. Gavin, can you unmute and tell me what you and your partner came up with and why?
50. 50. Because five because 10 5 times is 50. Because if you count by tens, the fifth time you count by tens, it'll be 50.
Hey, I'm smiling. Nice job. I like your explanation. So who is your partner, Gavin?
Well, actually, I had 2 partners.
Who were they?
Clara and William.
So a shout out to you guys. Nice thinking. So you could have written 5 times 10 is 50 or 10 times 5 is 50. You should have gotten the same answer, correct? Yep. All right. If you agree with Gavin and William and Clara, give me some sparkles. And I want to give a shout out to everybody who's labeling their units. That's a hard thing to remember. All right. The next part of our success criteria today is something I never thought I would teach in 3rd grade. But actually, 3rd graders love it, don't they, Mrs. Harrison? They do. I remember when variables was just a skill we learned in middle school. So that's okay. You guys get to brag. How many of you have older siblings? Okay. You get to brag about knowing what a variable is. You can say, today in math, I learned middle school math. So pretty cool, yes. All right. And a hush fell over the crowd. So variables are letters in math. That's like algebra, right? So you're probably thinking, wait, I'm 8, Mrs. Aubin. I'm only in 3rd grade. What are you doing? Actually, it's great to start now because then algebra, Abby, is not going to be so scary. All you're going to be thinking about is that a variable is a letter that is representing an unknown number. And you might still be thinking, what is she talking about? But watch. Turn to the next page, which is 35. You can follow along with me. It says when you write equations, you can use a letter, girls, whole body listening, please. You can use a letter to represent an unknown number. This letter is called a variable. What I like to do is how I explain it is the box. Do you remember at the beginning of math when we were reviewing? And I said, oh, everybody missed this problem, 18 divided by 2 equals, and I had of course, no, 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 okay, hold on. We don't want you, Puzzle Penguin, not yet. I'm going to write it over here because it doesn't want me to write it there. So I can do that. So we had 18 divided by 2 equals, and we had a box. Give me a thumbs up if you recognize the box. If you recognize the box, you can do variables. The box is synonymous or the same as a variable. It's an unknown. It sometimes has a question mark in it, right? We don't know what goes there. So when you look at all these equations, think of the letter as a box. So when it says A times 10 equals 60, you're just trying to figure out what times 10 equals 60. Can anyone tell me? What is it? What is A?
6 times 10 equals 60.
So 6 times 10 equals 60. So really, A equals 6. Let's look at the next one. 70 equals C times 7. Think of that C as a box. What in the world would C equal?
I don't know.
What 7 times what equals 70? Think of your count, guys. Josh, do you know? Still thinking. Elena, what have we been counting, Barb? 7 times 10, right? So C would equal 10. And we would just keep going. So W would equal whatever 80 divided by 10 is. How many 10s are in 80? If you know it, say it. 8. So W equals 8. It's just it's another way of having an unknown. Like, what is that supposed to be? What is the missing divisor? What is the missing factor? What is the missing product? Let's do one more. P equals 9 times 2. What would P equal? 9 times 2. Do you know it, Charlie? Multiplying by, so you have 9 fingers, count by 2s 9 times. 2, 4, 6, 8, 10, 12, 14, 16, 18. That's the one we miss a lot. Remember, I just wrote it up there too.
18.
So 9 times 2 is 18, or P equals 18. So let's try some of these. You have 1, 2, 3, 4. I want you to work on. See if you can figure out what those variables equal. So you're going to do numbers 7, 8, 9, and 10 on your own, not in a breakout room. Everyone's just going to work on it for a couple minutes. I'm going to see how long it takes. When you're done, hold it up. And if you need a little help, raise your hand and I can come around. If you have a question, write it in the chat box if you're unsure. Hi. So it's a missing, so what would be 7 times 12 equals 14? How many 7s are in 14? Think about your addition, your double. Try 90 divided by 11 is 9 times 12 equals 3. All right, I'm going to give you guys a hint. Think about your count bys. We're practicing. We've done our 5s. We've done our 5s. We've done our 2s, and we've done our 10s. I want you to use those numbers first to try and see if it works. For example, 14 equals 7 times. Let me try 5. 7 times 5. 5, 10, 15, 20, 25, 30, 35. Nope, can't be that. 7 times 2, that was the next one we did. 2, 4, 6, 8, 10, 12, 14. There it is. 7, so A must equal 2. This was a lot harder than I thought. Okay, I'm going to give you just a second to hold on to that. So be thinking, is this going to be a 5? Is it going to be a 5, a 2, or a 10? All right, what do you guys think? 10. All right, why does G equal 10? Who can explain? Go for it. Excellent. So you might have had to say 9 times what equals 90? Do the inverse. There are 10 9s and 90s. All right, Sawyer, 10 divided by what equals 5? Is it going to be 5, 2, or 10? 2. Why do you think 2?
That's the pattern that I noticed. Because 2, 10, 2, 10. Because, yeah.
Okay, who can explain? Go ahead, Evie.
It's like a pattern.
Okay, but can you tell me why 10 divided by 2 equals 5?
Because 10 times
Abby said that works because 5 times 2 equals 10. Excellent using that inverse operation. Surnay, is this going to be 5, 2, or 10? For F. Let's give Surnay a chance. All right, well, we could try. Some of you are saying 10, but does 8 times 10 equal 40?
No.
10, 20, 30, 40, 50, 60, 70, that'd be 80. Let's 5. Let's see if that works. 8 times 5 equals 40. That makes a little more sense, yes? Okay, we're going to try one problem because that's all we have time for, using a variable. And we'll use variables more often than just today, so don't worry. Let's do this one here. Number 11 together. A box of straws holds 60 straws, okay? We know the total. There are 10 straws in each row. How many rows are there? Since I know the total, Cooper, am I going to multiply or divide? I already know the total. I'm going to divide. So I have 60 divided by 10. Now watch what I want you to do. Equals, I want to know how many rows there are.
I finished.
So we're going to use a variable.
I know the.
Do you have a variable?
I know.
Okay, so Finn, the goal right now is to get a variable. I want everyone to get a variable in your equation. We're going to do 60 divided by 10 because we know we have the total. And then the answer is the missing number. We don't know what the quotient is. So we're going to use an R. I chose R because it said rows. One other thing you need to notice about variables, they're always lowercase. They're not going to be capital. So you need to make them lowercase. You, Mrs. Harrison, are you okay with them choosing the variable? Because I usually let them be creative.
Something that you should use something that makes sense. Like if that goes with the problem.
So R
So
for
R
rows.
is perfect.
Okay.
We just try not to use O's or L's or those
Yeah, 'cause
letters
they look
that
like numbers.
Other numbers.
Okay, so let's see what we could do for this one. Ethan used 9 dimes to pay for his book. How much did his book cost? I need to find the total. Am I going to multiply or divide? Paxton, what do you think? I don't know the total. I have 9 dimes. I want to know how much money that is, right? So I don't know the total, so I can't divide anything up. I have to do what? Yeah, because I want to find a total. So I have 9 times 10, and I'm looking for a money amount. How much did it cost? So that's going to be in cents. What could I use? What do you think? What do you want to put? A C for cents? We could do a lowercase c. A D for dimes, okay? A B for books. C for cost. So we don't need to solve those. I just wanted you to get the feeling of writing a variable. Okay? All right, so that was our second success criteria. Show me on your thermometer how you are feeling about variables. And if you're in the middle, that's okay, or you're down, because Mrs. Harrison and I will be talking about this all year. We'll throw in those variables. I have found that my third graders put variables in when I haven't even asked them to do variables because they like them so much. Okay, I see you. Do you know what a variable is, Elena? It's a letter that is representing an unknown number. Do you know what a box is? Do you understand the box for the missing answer? Can you try to connect those together? It's just like a missing box. The box, empty box for missing answer, okay? I hope that helps, but we'll keep working, okay, babe? All right, this is the last one. And I don't know if we'll have a whole lot of, oopsie, let's go back. Let's quickly read the Puzzle Penguin. If we have time, I'd love to do one more breakout room, Mrs. Harrison, if you're okay with that, and that'll end it. All right, you can pay me back tomorrow. Dear math students, This is like an exit ticket. You don't have one today. Think of this as your exit ticket, Evie. We're testing our learning to see how we did. Dear math students, today my teacher asked me to write a word problem that can be solved using the division 40 divided by 10. Here is the problem I wrote. Kim has 40 apples and puts 4 apples in each bag. How many bags did Kim use? Is my problem correct? If not, please correct my work and tell me what I did wrong. Your friend, Puzzled Penguin. This is page 36. You're going to do this in a breakout room with a partner. And I want you to, we know Puzzled Penguin's usually not right. What did he do wrong? He has 40. He's supposed to divide it by 10. He said Kim has 40 apples and puts 4 apples in each bag. How many bags did Kim use? Okay, go for it. Have a discussion. See what Puzzle Penguin did wrong. This one's a tricky one. Angelique, do you need some help? Hey, Henry. Hey, Henry, can you go to your breakout room and see if your friends have the same answer? If you were working hard, can you go check and see if you have the same answer as them? Yeah, that's okay. Making your work. All right, kids. So I don't know where I went on there. I don't see myself anymore. I hope they can hear me. That is so weird. You can hear me? Okay, good. I just don't see myself anymore. I exist. That's good to know. Okay. So we talked a little bit here. I'd love to hear from someone at home. Mrs. Harrison, do you see anyone who could tell us what Puzzle Penguin was puzzled about? I see a lot of hands in person. How about anybody? Mine's not working anymore, so I can't see.
Okay, sorry. I don't have any answers yet.
Thank you, Clara. I'm glad you can hear me. I wish I could see you. I can't see you anymore, but.
I don't have any. Ask somebody to throw the chat for me. I don't have any answers.
Okay, I'm gonna pick someone from here. Abby did an amazing job. Abby, what happened with Puzzle Penguin?
He put a 10 instead of a 4.
He put 4 apples instead of how many apples?
10.
He should have put 10 apples in each bag, right? But he put the answer. He got the answer, but didn't get the right divisor. So you could have said something like, first of all, is his problem correct? No. My smartboard's got an issue here, sorry. No, you are wrong. I should probably tell someone about this. No, you are wrong. You should have put, now it's better. See here, he puts 4 apples in each bag. He was supposed to put 10. You should have put 10 apples in each bag, not 4, silly penguin. He's a little crazy. Can you think of a problem that you could come up with that uses 40 divided by 10? For example, I had 40 gummy worms. I divided them amongst my 10 friends. How many gummy worms did they all get? If you can think of your own word problem that comes using 40 divided by 10, raise your hand. Can anyone come up with 40? Elena, what do you got? I didn't quite hear that. I heard something about gummy bears. She had 40. Did she divide them amongst 10 friends or put them in 10 bags or put them in 10 of something? Okay, what's another one?
Karen uses 5 apples for her apple.
Okay, so we're going to do 40 divided by 10. 40 apples.
40 apples.
And she
And she has 7 friends.
Well, we're going to use 10, maybe 10 apple pies or 10 friends.
And she has 10 friends, and she gives them all out equally.
I love that you said equally. Haley, great job. Haley said Karen has 40 apples. She has 10 friends. She gave them the same number. She divided them up equally amongst her 10 friends. One more, and then we will. Jensen, we'll hear from you after this one. Go ahead, Ellie. There are 40 cats.
And 10 of them ran away.
Okay, so that's subtraction. Remember, we want to put it into a division. That's what I was worried about with that subtraction. So we have 40 cats. We're going to put those 40 cats into 10 different cages. Well, we wouldn't do that, would we? Crates, because they're going to go somewhere fun, like the vet. No, I don't know. How many cats are in each crate? What are you thinking, Jensen? I'm looking at the chat. Oh, he wasn't raising his hand. Okay. All right. It looked like it. Okay, guys, I wish I had even more time. I shouldn't have that on there, but use the thermometer. Tell me how you are feeling about our learning for today. How are you feeling? Ben is down. Okay, Ben, are you struggling with the word problems or is it the variables? Can you tell me?
I'm struggling with the word problems. I'm struggling with the word problems.
Can you say it one more time? And kids in class, can you turn off your voices?
I'm having some trouble with the word problems.
I understand that. It's tricky knowing whether to multiply or divide, isn't it?
Yeah.
So I just want you to remember that we are going to continue working on these, and then we'll talk about little tricks to help us. The one thing that really I think stands out is when you are multiplying, you're looking for a total number, like all together. And when you're dividing, You know how much you have and you're putting it into little groups. That's one way that helps me remember when I have to solve problems and I have to visualize that. So we'll continue to work on that. Thank you for your honesty and letting me know.
Okay.
Okay, I am going to stop sharing my screen. Nice job today. I'm so proud of my mathematicians. And